Today we're going to do a water electrolysis experiment, and this is all you need. Got a couple of jars there, drilled holes in the bottom, put little glass tubes in, electrolyted them in. Got some PVC pipe with holes got some bicarb of soda and some stainless steel mesh. You see it's got tiny holes. I chose mesh because that gives me a larger surface area, and it also facilitates ion migration. And to power it all, we've got a very small power supply, and basically it just these go there. Basically it goes a little something like this, and that's one electrode, and here's the other one. You can just do it like that. And I've got the joins at the top. They're just tin copper wire, crimped. I've bent the tabs over and just crimped them with a little bit of pressure. They're not welded, they don't need to be. It's very low voltage, low current, and basically how it works is the holes face each other as close as possible, and now that's sitting inside an electrolyte, which is just water, and we add a little bit of bicarb of soda. And why we use bicarb of soda and not salt is if we use salt, we're going to have production of hydrogen and chlorine, and we do not want chlorine. We want hydrogen and we want oxygen. And if anyone's smart enough out there, they could make a very small model of this, a very compact model, powered by batteries or solar or wind or whatever you want to power it by, and you could use this to assist yourself in low oxygen environments such as at the top of Mount Everest or something. I'm surprised nobody's come up with a small oxygen generator for mountain climbers. A lot of people die up there on that mountain. I'd love to climb it. I don't think I'm the fittest person in the world, but I'd be pretty confident I could climb it using an oxygen generator similar to this. These have been known for years. They do work, so we're going to assemble it. We're going to add the water. We're going to add a little tiny bit of bicarb of soda to the water, and I'll demonstrate to you water electrolysis of separating the water into hydrogen and oxygen. Now, before you get excited and think, oh, that's free energy, fuel, whatever, it's not free. It costs energy to produce the effect. It costs energy to separate water into hydrogen and oxygen, and when you recombine it, you'll never get out what you put in. It's under unity, so it obeys all the conservation laws and laws of thermodynamics. But if you've got a free energy source, like maybe a wind turbine that you're using for something else, you can tap energy off that, then sure, you can pump out nice clean oxygen to boost the oxygen levels in your house, and you could also store the hydrogen, compress it, and use it for a hydrogen cell vehicle or hydrogen heating for your house. I'm very wary of hydrogen. It's highly explosive, and it really needs professional application, not some backyard do-it-yourself pipes leaking, explosive, hazardous sort of thing. So just be warned, do not try this at home. I'd try it out in the backyard where you've got plenty of ventilation, and see what you get. Now, as you see, the power supply is sitting on 2.5 volts at the moment. We'll start it off at 2.5, and then we'll increase it, and then we'll talk about it once it's going.